Welcome to the our learning session. Today I'll be continuing our homework three, and try to finish it today. So we'll tackle question number 4. We'll tackle what comes out of question number 4, and the text is that now you have loaded data. We want to analyze how and have familiarized yourself with the data structure. It's time to get your hands dirty. Now we are supposed to do some exploratory analysis using functions such as mean, standard deviation, min, max, sum, etc. These are the basic functionality that R provides to do the data profiling for data you have. Now, question number 5 says, what is necessary to add option in a remove equal to true to the above command? Why is that? We want to remove the null values from a data set before we compute any statistics on top of that, because we want to make sure that we do not include the rows that have null values in a statistics. Otherwise, the the values what we compute will be biased or incorrect. So that's how we need to remove those values. And it says that now we have done this thing, we can also use some different summary functions such as end distinct and other functions such as mutate and summarize to understand your data set. Now, question number 6 is, what is the sample mean and standard deviation of adults in fertility rate in 1960? Can you tell me how to do this? One way to do this is to use a mean function and standard deviation function. Now, before we go into that, let's look at the our let's look at the data set first. And this data set we have. Now, we are supposed to focus on a particular column of this data set, that is column 1960. This is the column we are interested in. This is the column we are interested in, and let's run it. And it says that there are null values here in this column. What we need to do is we need to see what we can do about this. When you compute, we can do mean of this variable or this column and NA RM equal to true. And let's see if we run this, what we get. What we had was, where I made mistake was that I put small x instead of capital X, and that's why it was complaining that it did not find the column. Now I have corrected column name, so show us that the mean of this column is 101.332, but there are 4 decimal places here. How can we round that to 2 decimal places? Can you tell me? Let me show you. Let's use round function here and copy and paste inside it. And let's do two places such that it is two decimal places. And we get 101.33. And this is actually what we're looking for. Now, similarly, let's use standard deviation function provided by R. And let's do, instead of mean, do ST here. And let's see what we get. And we get 54.21. And that's exactly what we're looking for. Next, we have question number 7, which asks, what is the sample mean and standard deviation of adolescent fertility rate in 2000? Now, year is different. We have to calculate the fertility year rate of 2000. It's similar to what we did earlier. The only difference is that in this time, we'll be using word 2000 instead of 1960. Now, we'll just replace 1960 with 2000. And let's see what we get. What do you think we'll get if we run this? Can you tell me? Let me show you. Once you run this, we get 63 as a mean and 46 as a standard deviation, which says that the distribution of values in 2000 is much narrower than what we have in 1996. The fertility rate is getting smaller than 1996 in 2000. Now, question number 8, true or false? Based on results from question 6 and 7, we can conclude that adolescent fertility rate has had a permanent decreasing trend from 1960 to 2000, and that dispersion of this variable has decreased over time. What do you think? Is true or false? Can you tell me? From what I think, this is false because we cannot definitely say that. We can just see we have only two data points here, and we don't have, and there's a loss of gap between those 2 years. Therefore, we cannot conclusively say that it has been decreasing from 1960 to 2000. Therefore, it is false. So, let's summarize what we did today. We talked about we talked about explore data analysis in R using some statistics function that R provides, such as mean, standard deviation, mean, max, sum, etc. And we also talked about some Doppler functions that that specifically provides by Doppler, such as indistinct, summarize, mutate, etc. And we tackle a few questions for adolescent rate in 1960 and 2000 and try to compare between those two and try to get some judgment on whether we can make some hypothesis about those 2 years. That's all for today. See you in the next session. Thank you.